So I'm going to walk through a complete database normalization project from start to finish. I was given a denormalized CSV file called orders raw data, so that contains order data from a small business. And the file had 12 columns and 23 rows, and everything is crammed up into one flat table. So things like customer info or net product info, supplier info, and just order info all mixed together on every single row. And I'm just here to make a messy flat file normalized. So that's what I'm gonna do. So the very first thing I even did before really touching the data, which I didn't really show here because I had to delete it because it was saying a lot of duplicates and stuff, but I did make a staging table, and a staging table is a temporary holding area that mirrors the exact structure of the CSV file. So it has 12 columns and no constraints whatsoever. So there's no primary keys, no foreign keys, no rules. So like the whole point is just to get the raw data into the database as quickly as possible, so without any validation getting in the way. I used integer for order ID and quantity, and date for order date, numeric for product price, which is really important for currency because it avoids floating points, so rounding errors, so and like all that. And I used varchar for all text fields and char for customer state because the US state codes are always exactly 2 characters. And so this table is just not meant to be permanent, but it's just a bridge between the raw file. So that is what I use to create my table. So as I want to start right here, which is where I actually just inserted my rows from the CSV. I just inserted all 23 because it was just like not working for me to download it. So normally in a production environment, you would kind of use the copy command and just load the CSV entirely, but we're working with locally. I'm using a direct insert value statement with all data hard coded. So this kind of just gives the exact same results though, which is good. And if you look at the data, you can immediately see the redundancy issues are in the entire thing. So like for instance, order 101 has 3 rows. Bob Martinez information repeats 3 times, and the wireless mouse $29.99 appears like 4 separate times across different orders. So text supply co from the USA appears 7 times. Wow. Okay, and then the USA appears a lot as well. So this is just a lot of wasted space and a lot of opportunity for data just to get out of sync, and that is exactly the problem that normalization will solve. So as I scroll down and just kind of scroll back, I had to design a schema. So like after analyzing the dependencies of the data, I identified 5 entities, which were customers, suppliers, products, orders, and order items. Yeah, there was order items. Yeah. So let me just walk through each table I created and explain it. So the customer table uses like serial for the primary key. Yeah, I did, which auto increments like it assigned customer IDs automatically. So I put a unique constraint on email because email is the natural unique identifier for a customer. So every column is just not null because a customer without a name or city is just useless. The supplier table over here is also similar. So it was also unique. And to prevent duplicates on the supplier records, the product table had a foreign key. So to suppliers, because every product comes from one supplier, I used numeric for, price, because I didn't want to use float for money because floating give you like results like 29.999001, which is like insane. Like I had to check constraints to make sure the prices is just never negative. So the order tables, like the order table was just kind of preserved as the original order ID from CSV, as it's, the primary key, since those IDs are already really meaningful, and it has a foreign key to customers. So the order items table was honestly the most interesting one to me. That one just sits in the middle and just kind of connects orders to products. It has a foreign key to both orders and products. I added a unique constraint to that one. So like as a combination of order ID and product ID, because the same product should only appear once per order. So the foreign key to address like it on delete cascade, meaning if you delete like an order, its line items just gets deleted automatically. The foreign keys like to customers, suppliers, and products use on delete. Meaning that you can't delete a customer or product that still has records, just depending on it, Now so I also started moving like the staging table from the normalized table. So like the order I did this in matters because of the foreign key depending. So I had to populate parent tables before child tables. So suppliers has no like dependencies. So it goes kind of first, So is this frozen? No, it's not frozen. Okay, it's okay. Okay, so it clearly shows that I automatically filters duplicates, so even though like tech supply code shouldn't appear 7 times in staging, so it filters it out. It only gets inserted once in the suppliers table, so the result is that 4 clean unique supplier records will be there, which are Keyboard Masters, Office Pro, Paper Trail, and Tech Supply. But that was for the insert into suppliers. That's what that one does. And the insert into customers over here, that one was just so that like Alice Johnson appeared like 5 times in a row, and across 2 different orders she appeared 5 times. So we selected distinct, collapsed that down to 1 clean like customer record, so we end up with 6 unique customers: Alice Johnson, Bob Martinez, Claire Nguyen, David Park, Fatima Rashid, Grace Kim. I mapped out the customer email from staging to the email column in customers, so the column names are way different, so I have to be really explicit about that. Inserting it into products is a little just different because I store the number for whatever ID that was assigned. like the number points back to the one row in the suppliers table that has all the supplier details. So we end up with like 8 unique products, which were ballpoint pens, I'm pretty sure, desk lamp, mechanical keyboard, monitor stands, notebook pack, standing desk, USB-C hub, and wireless mouse. Those were the ones that, yeah, that was there. And then the populating orders were just kind of where the customers just needed the customer ID foreign key. I did join the customers table on email to look up the right customer ID. It's just I used to select distinct, which was very important because order 102 had 3 rows in staging for Bob Martinez, and it should have been only one order record. So I used distinct collapses those 3 rows into one, so we end up with 10 unique orders. So like one for each order ID from 101 to 101. I'm pretty sure 1010. Okay, let me just scroll. Down, am I scrolling down? Oh yeah, right here. So this one's a little, I wanted like all 23 rows because each one represents a unique line item transaction. So we end up with 23 items and the record, which matches the original CSV exactly, which was perfect. Insert into order items and selected it, and yeah, I ended with that. But honestly, before really just running even the queries, I had to verify the row count, so I checked 5 tables at once. I expected customers to have 6 rows, and suppliers had to have 4 rows. Products had to have 8, orders had to have 10, and then order items had to have 23. So if any of these numbers are wrong, it means either duplicate slipped through or data was lost during the entire thing. So when all 5 numbers matched, I knew the data was clean and I can trust my query. Okay, so if I scroll right here, it just kind of means that, like, for instance, like the first sample of the query is really the most important one, so it proves that normalization did not lose any data. So I used 4 join statements to resemble all 12 of the original columns from across the 5 normalized tables. I started from order items because that is the center of the schema, you know, like order items and order ID. Order items. So like I started from there, and like I just joined from outwards to orders to get the order date, and then to customers to get the customer info, and then the products to get the product info, so, and to suppliers to get the supplier info. So I kind of did that, and then when I ran this query, all 23 rows came back with all 12 columns identical to the CSV, so that is proof that normalization process was lossless. So the data is now stored efficiently in 5 separate tables, but they can also be reconstructed in full at any time. So, and then like the second part of the query is kind of just like an aggregation, I'd say. It just kind of calculates the total revenue per customer, so that's the kind of business insight that is easy to get from like a normalized database, but would be really messy to calculate from the flat CSV. but I multiply product price by the quantity, and then for each line item to get the line total, then just summed it up like per customer using the group by. I also used to count these things, which in order I need to see like how many separate orders each customer placed. So like order by total revenue, and it kind of puts the high spender at the top. And it showed that Bob Martinez and David Park were at the top, and they were both around like 535 to like 555, which is, you know, Alice Johnson placed 2 orders but spent less because she bought way smaller items. So Grace Kim only placed 1 order and was at the bottom. So I'm just trying to see this. I just like for the third part, the Curie kind of just filled out the electronics category. So yeah, electronics was just filtered, and the ranks products by revenue. Yeah, so yeah, electronics was filtered, and then I just kind of grouped by products to aggregate it to see like sold and total revenue for each electronic product. The results told like an interesting story. So the mechanical keyboard generates the most electronics revenue, which is at $269.97, even though only 3 units were sold. That is because it cost $89, well, $9.99 each. So the wireless mouse sold the most units, but only generated $149.95 because it's a cheaper item. So this just shows in general that the revenue and the unit volume tell different stories, and a normalized database makes it really easy to analyze both. So that just kind of concludes everything that I was doing. Yeah, that's it.